Hello friends, now in this discussion we are going to be looking at questions and answers about programs or programming in AVR and C/C++ all for embedded systems. So to begin with, how are delays typically represented in AVR using C? How are delays typically implemented in AVR using C? So A, using delay, ms, which means milliseconds, function from util stroke delay. Of course, we are talking about in this header file. So using the delay function in the header file of this, then B using an infinite loop, and C using a system call, D using the thread.sleep function. So the answer is going to be, how do we implement a delay in AVR? So using the delay function from this library, I mean the header file, of course, it is also a library. So the explanation is that this header file provides delay functions like delay ms function for generating software delays, and these are commonly used for simple timing tasks. Next is that which of the following is an advantage of using C++ in embedded systems? A is object-oriented programming for modular code. B is slower execution than C. C is limited hardware level control. D is dependency on external operating system. So what could be the better advantage here? So is A, object-oriented programming for modular code. So C++ supports object-oriented programming, which enables modular and reusable code. Okay, this can simplify complex projects while maintaining control over the hardware. That is very important. In AVR programming, how can you write a high signal to pin PB2? Okay, so you would write A port B, okay, and you put PB2 here, you'd write port B here, ampersand, then equal to, approximate, okay, then you have PB2 here. So which of the four you're going to use to write a high signal or to send a 1 to PB2? So the answer is A, and we shall find that the bitwise OR operation combined with the left shift 1, okay, shift PB2, sets the PB2 bit in the port B register 1, outputting a high signal on pin PB2. This is amazing. So this one, the one with the bitwise OR operation with the left shift is what we are going to use in outputting a high to PB2. So let's continue. C++, we have just talked about the basics for AVR, but let's continue for C++. So what is the primary advantage of using C++ in embedded systems? Okay, it provides a higher level abstraction for hardware access. It offers object-oriented programming features like inheritance and polymorphism. It simplifies the management of memory and hardware resources. It reduces code size by eliminating unnecessary features. What is the answer? So, as we had earlier on said, is that C++ supports object-oriented programming. So, we find that it is B because it offers object-oriented programming features like inheritance and polymorphism. So, As we had said, C++ is an object-oriented language that allows for more modular and reusable code, which is especially useful in large embedded system projects. Which of C++ is commonly used in embedded systems to manage hardware peripherals? A. Classes and objects. B. Exception handling. C. Operator overloading. D. Templates and generic programming. So the answer is classes and objects. In embedded systems, classes and objects are used to represent hardware peripherals, encapsulating their functionality and providing a clear interface for interaction. Which C++ feature is used to improve the performance of embedded systems by controlling memory usage and hardware access? So we are talking about pointers and references. B. File handling. C. Template specialization. D. Exception handling. So which one is used to improve the performance by controlling memory usage and hardware access? So we use pointers and references because pointers and references are crucial in embedded systems as they allow for direct memory access, improving performance and providing an avenue for better memory management. Which C++ key word is used in embedded systems programming to declare a variable that should not be optimized by the compiler? So we are looking at A. Const. B. Volatile. C. Static. And D. Extern. So the answer is volatile because the keyword volatile tells the compiler not to optimize the variable, which is important in embedded systems where hardware registers or memory locations might change unexpectedly, e.g. due to an interrupt or hardware event. Which C++ feature is often avoided in embedded systems due to its overhead and complexity? Function pointers, exception handling, templates, and polymorphism. So exception handling is typically avoided in embedded system because it adds runtime overhead, which is often unacceptable, and that is in especially resource-constrained environments. So where you have resource-constrained environments, it is unacceptable to use exception handling because it adds runtime overhead. And we know that exception handling is a programming mechanism used to handle runtime errors or abnormal situations or exceptions in a program in a structured manner. In languages like C++, it allows a program to respond to unexpected events such as invalid inputs, resource allocation failure, or system errors without crashing. So if you bring in a provision for this, you're going to have runtime overhead in your programming. And where you have resource-constrained environments, for example, memory, it is unacceptable. And this is typical of embedded systems. So what is the purpose of the hash-defined directive in embedded C++ programming? So we use it to declare global variables, to define constants and macros, to include external libraries, to handle exceptions. So the answer is B, to define constants and macros. So the hash define directive is used to define constants or macros, which can be useful for setting fixed values or simplifying repetitive code in embedded systems. So in embedded systems, why is memory management in C++ often done manually using pointers? So to reduce the size of the code, B, to avoid dynamic memory allocation overhead, to use higher level abstractions, to use automatic garbage collection. The answer is B, to avoid dynamic memory allocation overhead. Explanation is that manual memory management using pointers allows more precise control over memory usage, which is critical in embedded systems with limited resources and no garbage collection. Which of the following can be used to create reusable and modular code for hardware peripherals in embedded systems? So A is templates, B macros, namespaces, D exception handling. Which feature of C++ can be used to create reusable and modular code for hardware peripherals in embedded systems? So templates are very important because they allow for creation of generic code that can be used with different types, helping in modular design for various hardware peripherals. In embedded C++ programming, what is the role of the inline keyword? So the inline keyword, A, it prevents the compiler from optimizing the function. B, it forces the compiler to generate inline functions, reducing function call overhead. It defines a function that can be called from other files. It allows the function to throw exceptions. So the role of inline keyword. The answer is B. It forces the compiler to generate inline functions, reducing function call overhead. So the inline keyword helps in reducing the function call overhead, which is important in embedded systems to optimize performance and reduce code size, since embedded systems are always having constraints of memory size. Which C++ feature is most commonly used to handle hardware interrupts in embedded systems? Functions with specific signatures, B, operator overloading, C, virtual functions, and D, multiple inheritance. The answer is A, functions with specific signatures. In embedded systems, interrupt services routines are typically defined as regular functions but with specific signatures and constraints. So there is no use of dynamic memory or long computation. So ladies and gentlemen, we are going to be discussing ATmega 328 microcontroller programming using C or C++ in our next lecture. Keep tuned in, subscribe, like, and share this video.